Live stream. Okay, so two things on my plate we can get through quickly. Number one, not sure if you guys saw in the Slack, there was someone asking about M1 support, and I kind of gave a summary of what's been discussed before, but he volunteered, Martin Fecky, to test it out when it's available.
Okay.
He apparently has an M1 device. Next is Leonardo, I think was his name. Leonardo Ostera, who is running the LAM project. Paul, the article I think that you linked in like 2 weeks ago, I reached out. You weren't on last week, Paul, but I reached out to him to see if there was opportunity. I think I mentioned this in the channel anyway, for us to kind of like maybe just chat with each other. He's up for it. I invited him to our stand-up, but he didn't respond on that one. He is in he's in Stockholm. He said he would be available today or Friday after 5:30 p.m. Stockholm time. So I'm not sure what time zone Stockholm is
like
in.
1 or 2-ish.
I think it's
1 or 2-ish. So I told him I'd get back to him on everyone's availability. Does Friday at that time work for everybody?
Yeah, I should be able to make that on Friday. Yeah.
Paul and Hans, Luke and Hans.
Yeah, I think that
I think so.
Okay, I'll send out a calendar invite. He has already spoken to the Lunatic team. I'm not sure if you guys saw the article that I put in there, but there seems like there's another actor-based Erlang-ish WebAssembly effort. And this seems to be like a company that is
that one's a little
product.
bit different. Yeah, they're building more of like primitives for WebAssembly to construct actor-based systems versus something specific to Erlang Elixir. But
yeah, I mean, it may be someone else to chat with as well. It seems like that there's and perhaps some additional voices we can get into the working groups to push on certain things if we all need them, which would be great.
Yeah, I was going to say that we probably have overlapping requirements in terms of like the stack switching stuff and those kind of efforts that we need. At least some other, teams that say, hey, we want this.
Yep.
I missed the stack subgroup meeting yesterday because I had a conflict, but be interested to hear from Luke too once he gives his update on how that went.
Cool. After our talk with Leonardo on Friday, I'll reach out to the Lunatic team, and I mean we'll probably hear from him on what his conversation was like, but it may still be worth us touching base with them. And that's it from me. Oh, last thing was, I'm not sure if you guys saw, but Jim put out a survey on ElixirConf. I guess he's trying to gauge interest and see if there's potential for an in-person ElixirConf. But the one thing that I took note of is that he's looking at maybe October for the dates. Like I heard from him, we chatted over email, and it looks like ElixirConf Europe is now in September for the remote conference. And so he's trying to put a little bit of distance between him and that. I think he actually runs both, but he's trying to put the difference between the American one and the European one. So if there was interest on us doing something there, I know that you guys are resistant to the whole kind of conference-based scheduling, and I understand that. But just October seems to be where he is thinking right now.
Okay, I mean, we can at least tentatively kind of like focus around that time frame anyways for our own milestones. But regardless, one way or the other, if there is going to be a conference, then at a minimum it might be worth going if we're able to.
I think there will be a conference one way or the other. It's just a matter of whether or not it's in person or remote.
Right. I guess I mean more in person. The remote ones I'm less interested in personally, but I know some people enjoy them. So
yeah, I mean, I kind of liked LexerConf last year only because of the hallway tracks and people were kind of jumping into their own Zoom channels. I found that interesting, but it was more of a novelty than anything else. I don't know if I would really be. It was free too, so I guess that was really the thing. I'm fortunate in that I'm actually going to be getting the vaccine next month. I volunteer for my town's high school in a coaching capacity, so I'll be getting it early, and
Nice.
presumably then I'll be able to travel. But hopefully, also by then, most if not everyone will have. I mean, by October, we're hopefully going to be all vaccinated up. So we'll see.
Kids are
Seems
iffy
that
by
way.
then. It's expected the trials for like 6-year-olds, like the 9
Yeah.
to 6-year-olds won't finish until September, so that's iffy.
Right. Sorry, I meant adults. You're right. Okay, so let's my order here. Paul, you're in the upper left today.
Yeah, so I guess what I've been trying to get wrapped up is the major set of changes around kind of refactoring CodeGen so that I can start targeting WebAssembly. I was able to, over the last like several days here, spend more time on that than I have for a long time now. So that's just about wrapped up. The main thing there is that the order in which things happen allows me to treat all targets as one, like with one IR, and do a lot of work there, and then choose how to target individual platforms. So I think probably the initial plan here for WebAssembly will be to lower that as kind of like an asyncify like translation using coroutines. It's not going to be very performant, I don't think, but it remains to be seen how that will play out in practice. The nice thing is that we can actually test, its performance on x86-64 and do kind of side-by-side comparisons in terms of how that lowering works. But that'll at least give us a bridge, some kind of way to target WebAssembly in the near term, regardless of what happens with the stack switching stuff. Obviously, it's not ideal, but it's something.
It's still faster than the current WASM way where like we completely have the stack in memory the way I'm doing it now, though, right? It's still better because we're using the WASM stack a little bit, right? With the asyncify approach?
I mean, it will be, it's hard to judge, to be honest. I think the reality is that because of the allocations required for each continuation point that needs to be constructed, you end up with a lot more small allocations. But since we, in theory, control how those are allocated, we can probably make that more efficient. I haven't, dealt with the runtime aspects of that just yet. It's mostly just from a CodeGen perspective, but there's probably some things we could do to actually make it more performant on WASM versus kind of the way we've constructed our WebAssembly like demo so far. But yeah, I mean, until we actually can see it side by side and test the actual performance differences, I'm not sure that I can comment one way or the other on how it's going to perform ultimately. My intuition says that it's not going to perform particularly well, but that's just an intuition. I don't actually know for sure. Based on some of the experiments I've seen in various research papers and little projects people have put together to kind of experiment with these different approaches to, kind of green threading in WebAssembly, it seems like this transformation is the best approach available so far, but I mean, I don't think it's going to hold a candle to how we would do things in an ideal world, but we'll see. As far as the support for the M1 processor goes, I have a little bit of work left on that, but I haven't been able to find time to wrap that up. But I want to get this big change set merged first and then wrap that up.
Yeah, I think the WASM stuff is the priority there.
And I think in theory, You should be able to use Lumen compile for x86-64 and run that on the M1 because of the Rosetta,
Rosetta?
2. Yeah, but I don't know for sure. I haven't obviously tested that, but it might be worth seeing if it runs under Rosetta. If it doesn't, then there's not much we can do about it. But
Yeah, I think most of the things where programming languages have targeted is because they were detecting the M1 and being like, oh, we don't target this. So as long as some dependency we're using doesn't do that, it probably just works. It's just not optimized and targeting the M1 actually. But since Rosetta is like it's an ahead of time optimization, it's not a runtime translation. Like the install will be slightly worse for the first run, but after that it'll be fine. It runs as
compiling Lumen on the M1 might be the tricky part. But if you already have compiled Lumen executable for x86-64, I think if you take that and run it on an M1, it should work. But we'd have to test, I guess.
Can I I know we discussed it over the past few weeks as well, but I just want to better understand the stack switching issue and what is the resistance on the specification for it.
I wouldn't say it's so much resistance, so much as it's just basically trying to flesh out.
Well, not that either.
A little bit of indecisiveness, I guess. It's more like we know this is needed for a variety of reasons. And it's a tricky topic because of its interactions with other parts of WebAssembly and JavaScript. And we want to make sure that, we vet all the approaches and choose the right one for, regardless of how long it takes. So basically, it's just going to drag on for however long it takes to find kind of the sweet spot here. I think we're probably nearing the point where, we've covered a lot of the initial kind of like, here's the options. And they'll have to start iterating towards like something more final. But I would say by the end of the year is optimistic, probably.
Yeah, the problem is that the stack switching group is only every month. So it's a slow process. I can cover what happened in the meeting if we want to jump to that, since it's related.
I just had one last question before we get into it. Was let's say magically they finalize the spec tomorrow. What are we looking at realistically for implementation time?
We need LLVM to support it, and maybe Rust, but probably not.
No,
because we just drop into ASM, and so it'd be fine.
Just need the support on the WebAssembly side, and we might even be able to bridge that gap with like inline assembly or something, but we probably want to wait for LVM.
And this is going to be one of the major performance bottlenecks for us?
I guess that remains to be seen how the async type lowering actually performs in practice. If what we find is that it's slow, then that would be kind of a blocker there. And I think, from the discussions I've had and, have overheard, there's awareness that is not an ideal approach, right? That it's kind of like this, way to bridge this gap for some time until, proper primitives to this kind of stuff can be provided. But that doesn't, help them move any faster on it. It's just
all right. So I guess as far as our messaging goes, when the WASM PR lands, then we should probably profile it and understand what the real world performance characteristics of this are, because we don't want people saying, hey, WASM is here, Lumen's ready, let's use it, and the performance sucks. They're going to say, fuck this is a waste of time, and not come back to it, right? We just got to make sure that the expectations are set properly before we go out and kind of advertise the WASM PR having landed.
Yeah, I mean, there'll be two stages to this anyways. One is getting the changes that I've been working on merged, and then the second step of it will be covering the runtime aspects of it. But then, yeah, we'll be able to do, and we don't necessarily have to say like, oh, this PR is like WebAssembly stuff. It's, general improvements for a variety of things, but we could spend some time doing testing, kind of while keeping it more or less, toned down while we, review, and then go from there.
Yeah, I mean, you understand my point though, right? Like people hear WebAssembly and they think fast, and if they don't get fast without understanding the reason why or having their expectations set, they're just going to think that the project is not heading in the direction they want. So we just have to,
For sure,
set the tone. Okay.
Yeah, agreed.
Sorry, Luke. Luke, you're muted.
The reason why we're doing this separation is explicitly because WASM's like the spec's not ready, and so like this way, like the yield infrastructure is generic, so that if they change their mind, we can target the new way, and then that will be like very clearly like, oh, it's the browsers that aren't ready, it's not us.
Yeah, no, I totally get it. I'm hoping that what we'll see is that the performance is good enough for most things, and then when this change happens sometime in the future, it gets part of an update of Lumen, and then all of a sudden there's like, oh wow, additional performance. Thank you.
I mean, it's still gonna be the case when this lands that the big hit is going to be like that OTP doesn't build. Like it's not going to be that we don't support WASM.
Yeah, no, I understand. Anyway, Luke, you said you wanted to get into the meeting.
Yeah, so the Stack subgroup this month was so the thing that Francis, the guy that leads the subgroup, has been covering is pushback from the JS side that like WASM introducing stack switching cannot allow JavaScript to just transparently coroutine. Like it is a huge concern. Like JS will push back and be like, fuck no, it's not going in the browser. You're not breaking the internet. You're not breaking the web. And so the presentations were about Luke Wagner came up with a proposal for how to both to not transparently like that JavaScript could never transparently do it, and using the pre-existing like promise infrastructure. So like there were previous presentations about const suspend and const resume, which someone actually implemented in WASM time, I think, for one of them. And then, but the point is that this event would percolate up, and he showed 3 levels of API of like, one is like just seeing the event and like looping on it, like the way promises are implemented inefficiently, and then going all the way up to like a full async API. And that one would work and allow WASM to be suspended just whenever it says suspended, it would yield back up to the top level thread. But also, if they do the low level one, it would support polyfilling of like WASM calling to JS and then JS calling back into WASM, and then like the asyncs uniting without violating the requirement from the JS group, like TC39, that they couldn't just be suspended without knowing about it, because they would have to know that they are getting that event, and then the JavaScript function itself would have to be declared, async or returning a promise, which is the same deal under the covers. And then mine was just when the whole point of this was like, is promises enough? Because the stack switching is built on top of effect handlers, and effect handlers in theory could have more than just async and promises. But this was mostly, and I mentioned like, oh, we already use promises for the handwritten Rust stuff. And then everyone was like, okay, how do you do that? And so I took out the part from the early presentations where I actually explained how we did that to show that like this works and promises work. And so Luke Wagner's API is a potential, but he didn't spec it out. It was just like, here's a thing we could do. But it seemed like it would work well. The one thing is his test case was like the WASM calls const suspend, but it doesn't overall declare that it's and that it's switchable. Like in theory, WASM could be switched that doesn't know, because WASM won't care that it can be switched. So he didn't show an example of the way we're doing it, where like we suspend one thread and it doesn't go all the way out to the JavaScript event loop. So I would want them to double check that will work, so that we can schedule without going back to JS, because that's how our request animation loop works right now. Is we schedule a process and it might use up a reduction, and so we'd be switching stacks without going all the way back to the embedding event loop.
Right. I mean, there's two things there, as you pointed out. One is being able to suspend the current WASM module to yield back to the browser's event loop. And the other one is to construct your own, green threading scheduler within the context of your WASM module. And for that, you need the ability to create, stacks that can then be used for threads of execution, and then be able to suspend and switch between those. And I don't like, there's multiple kind of threads the conversation with the stack subgroup has kind of gone off on. And it sounds to me like kind of the stack stuff has been kind of set aside for the moment. They're focusing more on the execution semantics of, if you have a stack. In fact, they're not even talking about stacks here. They're just talking about, suspending and resuming execution on the main thread.
Well, the thing is, the const suspend, when they first showed it, does work for multiple stacks, but it's definitely not like, it's just those two things of const suspend and const resume. There's no effect handler syntax for the stuff that Luke Wagner showed. Now, mind you, I was still writing the presentation while I was talking, so I may have missed some details, unfortunately. But yeah, so there's that concern. But the other one, so it'd mostly be whether his approach will work. But see, like, that's the internal to the WASM syntax, so like potentially it's not an issue, because his was more like, how does it interact with JavaScript to assuage Francis's concern that he's passing along from the JS people. And I think the API he made wouldn't change even if there were effect handlers, because the main point was that like it would it has a certain format to like, the Lolo API is not promise based. It has a specific multi-return like tuple structure that behaves similarly to a promise. And then Luke's like other APIs were just like, well, we know most people are going to use promises for this. So like, if we did that, can we make the API simpler and simpler? And so it got to the point where like, it was just like a bind async. And then all of a sudden you could call it like a normal function, and it would just work as a JavaScript async function without a lot of overhead. Or like, and the other way was that also like, you would be able to, because WASM would now understand like this asynchronous of functions based on the type signature, that you could pass in, browser's fetch, which is async, and it would just work. Like the JavaScript would suspend and it would turn into the WASM equivalent event that it suspends, and like it would just work on an import, was his point. So it was very much a web embedding focus, but since we care about that, that's kind of important. And if it gets over
also kind of, go ahead, continue. Sorry.
And it's important because right now we're worried about the JavaScript committee allowing this is blocking the entire proposal going forward, because I think Francis doesn't want us to pick a thing that allows us to violate the don't coroutine JavaScript without it knowing issue.
I mean, honestly, that part of it makes very little sense to me anyways, but I assume they're talking about the low level like engine implementation, not from a language level. From a JavaScript language level, you can't assume that you're not going to be preempted. It can happen at any point.
Preempted, yes, but there are actual rules that you're not like what can change on like what's called a microtask is actually fully specified. So like it is it's how JavaScript works now in the browsers. I don't know if it's technically how JavaScript, the language, has to work. I don't know.
Right.
I don't know if TC39 is like
really what I'm talking
browser
about.
JavaScript or actual JavaScript, like JavaScript outside in Node 2, probably, because people want the Node version. So TC39 might be both, like all the JavaScripts. And so the microtask thing is fully specified. And so like the fact that like if you check a thing and like this thing can't change out from certain things can change and they don't want to allow coroutining without the JavaScript knowing. Like they're okay with it knowing, and that's the async thing. But yeah,
I think the implication is that, you know, state visible to the JavaScript code cannot change except for when certain events occur, right? So if you call a function that is async, that would be one such example, that the state when the callback is executed may have changed. But I think calling a blocking function, the assumption is that, you know, visible state will not have changed,
right.
sort of magically. And I guess, yeah, it would be theoretically possible, you know, for that rule to be violated, depending on how things are exposed to WebAssembly. But yeah, I don't know. I mean, to me, the problem is kind of derailed a little bit because they're focusing more on async again, and that's one very like simple and different problem space than what we care about.
Right. So you have to, like, from the motivation perspective, Francis also represents like Google's like desire to actually have async, because Google's own websites like Google Earth want async, and like they want, like, Google Earth has a WASM thing already, but in general, any JavaScript code that's currently async, Google wants to be able to put that into WASM with an easy porting story, and they don't want to use Asyncify. So that's why they're strong on async has to work. And, you know,
Yeah.
we're there of like, well, make sure it's not just async.
Yeah, I think the difference, you know, can be summarized as the difference between stackless and stackable coroutines. And async is typically a stackless coroutine or implemented as one. You know, you might lower it as like a state machine, like the way Rust does. And there's other such lowerings depending on the language you're working on. But ultimately, you know, it's expected that you can capture all of the state for, you know, the continuation locally, where in our case we need them to be stackable because we want to switch between them and, you know, have a heap associated with that so that we can treat each one as its own unique thread of execution. And that does not have any real overlap with async. Maybe in some, you know, mild ways it might, but I don't really think it does. You know, you might have stackful coroutines that then call async functions. And there's, you know, overlap there. They're two separate things. One does not enable the other. Stackful coroutines can be used to provide stackless coroutines, but not vice versa. And
yeah, I would say
that's a problem for us.
One of the things that, like, even if we get even effect handler, well, so if we get effect handlers, it's slightly different, is that we might get the stack switching without a way to represent, without us being able to get access to the GC points, or like, not the GC points, but like the things that, without the ability to change, you know, without it being able to do compacting GC on the stack that's suspended.
Yeah, I mean, in that case, we
if
would just provide ourselves a shadow stack or something.
Right, and that's the expectation that we might still have to shadow stack if we don't get the part of effect handlers that they talked about that would allow us to do the GC. And so it still might be a little bit messy.
That's not an effect handler thing. The effect handler thing was a different, like, it's a more general control abstraction.
Right, but the effect handler, one of the ways was the thing that Ross Tate talked about with the answers was his way of being like, this is how you could do linear memory GC was on top of effect handlers. And so if it was general enough, we could do both with it.
Yeah, it's possible we could use that, but given how the conversation around that stuff has gone, it doesn't seem like they're talking about like the general level of control that you get in a language as first class effect handlers, which would give us the ability to implement things like continuations. But I don't know, that conversation never kind of finished playing out, so I'm not really sure where they landed on that, or if there's still stuff, in progress around that. But yeah, his points about like stack walking and being able to do traversal over, roots on the stack was something that would have worked for us. It didn't get the sense that was received well, and that people are like, yeah, we should go that route.
So the one thing that we might, so like, yeah, like Francis and Google are pushing their thumb on the async, but like Andreas Rosberg is like the creator of WASM from like the perspective of like the working group and everything, and like as the author of the spec. And he is the one that's pushing very much that he does not want a async only solution. And so that's potentially, good. Even if Francis is like, okay, here's assume we're going to use Luke Wagner's API, Andreas might go back and be like, well, this only does this. Let's just do effect handlers. And I think Andreas is also excited to like, I'm going to get effect handlers in a common language that everyone is fucking using. That's going to be fucking awesome. I kind of get that vibe from him as his academic vibe of like, look at this cool thing that people rarely use. It's so cool. Let's do it this way so we don't have to have multiple like things to implement it. So that might be a good reason why we get effect handlers. But as of right now, like no one is writing spec text. It's not even like, let's agree on the spec text. It's not even, like a phase 1 proposal for let's write the spec test. So that means it's at least 2 months away because, no one said they're going to write it and then vote on it next month. So yeah, it's slow. Brian.
Definitely seems like one of the major blocking issues right now is that, the requirements that, a suspended thread of execution cannot have any stack frames from the JavaScript stack, which surprised me. Let's say we spawn, a new stack that we want to start execution from our WASM module, right? Like the init function of an Erlang process. And then that inevitably calls a JavaScript function at some point. When it was explained, I did not see where the issue comes up with that. Now, on the main thread, when you have JavaScript calling into WebAssembly, capturing those frames in a suspended unit of computation definitely made more sense to me because you're going to be yielding back up to that frame and things will change. And I wanted them to dig a little bit more into whether that was a general problem or just a problem with, on the main thread with JavaScript calling into a WebAssembly module. But regardless, if that restriction exists, that's a problem.
It's not WASM calling into JavaScript. That's not bad because there's no way for the JavaScript to suspend because they won't, in theory, have the primitives to do this thing. The point is, and it's very clear in Luke Wagner's slides, which are attached. Like we don't. Like Francis doesn't want to record the videos because he thinks it changes how people talk. So unfortunately, we can't refer to that. And like the note takers aren't as good in the Stack group meetings as there are in the main one. But Luke's slides are posted and they're attached in the meeting notes. It's not the go down to JavaScript. It's the fact if you go down to JavaScript and then it comes back into your WASM module and then it wants to suspend. And so Luke's API is that like at that point you act async and like return a promise or this low level event that would be for all types of events. Then if that, and then to not violate the rules of if the JavaScript that's receiving that event isn't set up to know the WASM is going to do that, it will trap. If it's set up though to not trap, it will know how to receive that special return value type, and it then could choose to make a normal JavaScript promise that wraps that, and then that JavaScript could return that promise up the stack in a special way to the other WASM again.
When it's unwinding.
So it's unwinding. It's doing a WASM promise, a JavaScript promise, and then a WASM promise again, and that's okay because everyone knows they're async. Then it's very opt-in, and the important part is that if WASM pops out a return value, it is in a state where like the JavaScript has to be cooperating to be suspended.
So this is where I keep coming back to the difference between stackable and stackless coroutines. This model makes sense when it's stackless coroutines because you're on a single thread or a single stack. However, when you have multiple threads, like the state that JavaScript sees is in that stack, that thread. So if you suspend that thread and switch to another thread, like you're not violating anything from the perspective of JavaScript. They're separate heaps and everything. I guess maybe there's something here that I'm missing. I don't know. But I do think the conversation there has ended up focusing again on the async question, where that proposed solution works pretty well. I think I agree. But I'm not sure that it models our problem so much.
I mean, if you have a bunch of nested async functions and you await really deep, aren't you having the entire stack? Like you're not unwinding and replaying in the actual browser implementation. Aren't you actually suspending the whole stack?
Every frame there has a continuation allocated for it. So if you're in a function and you call an async function, you've got to construct that continuation there. And then likewise in that callee, if it's going to call something that's async, it also has to allocate its continuation and so on.
So
and so forth.
It's doing the struct and state machine thing the same way Rust does. It's just doing it.
I mean, not necessarily exactly the same way, but yeah, the essence is the same, and that each one has to allocate this way of understanding how to resume execution at that point.
I guess that makes
sense. When execution comes back, you replay every single frame to get back where you were. It's just instead of executing the whole function, you jump straight to the part of the function where execution was, suspended or yielded. And that's why it's, not great for the kinds of processing that, Erlang is good at, because in Erlang, you switch right back to where you left off. And you don't have to do any of that allocating bullshit.
I get that, but like the promise-based API is like the way that all the browsers are moving their APIs. It has to be optimized very well. Like I know it's not a single stack pointer, but like how they're jumping into a potentially very deep promise tree has to be optimized really well because they wouldn't be pushing the APIs otherwise.
I mean, I'm sure there's various assumptions about the way JavaScript works and the way they've, implemented their virtual machine for JavaScript that they're able to make that less problematic. I'm not sure that those optimizations carry over into WebAssembly since they can't make assumptions about the language. And I think fundamentally, they still have to do something like that anyways. It's just, the size of that state machine, that allocation is dependent on how many yield points you have in a given function. And they probably do things like split functions up and, try and omit allocating anything in cases where they can get away with that. I'm not 100% sure. I haven't actually looked at the VM implementations in a long time. So I don't recall how they're actually implementing that stuff, but there's no way to escape that with stackless coroutines, you have to allocate a continuation for any place that you might yield. I don't see how they could possibly avoid that. Now, they might have some tricks that let them, effectively skip jumping through functions. I mean, that's the other thing with JavaScript is that because they don't guarantee tail call optimization, and so recursion's not super heavily relied upon, stacks never get that deep anyways. So I think that's part of why that performance issue never really bites them too much. If they had tail call optimization, then it also wouldn't bite them very much, but they don't guarantee that. I don't know.
Do you think they basically do like a continuation passing transform on the JavaScript, like basically just transform it to like here's a promise with the callbacks and then just stack track the actual stack that's displayed upon errors in the promise or something?
That's kind of what I was wondering. Yeah, I seem to recall that JavaScript core did something like that. The WebKit JavaScript engine, but it's been so long since I last looked, I couldn't tell you for sure. But I feel like at least one of the engines does some kind of transformation like that.
Yeah, and that's the exact thing we want to avoid doing. So like even if they do it efficiently internally, I mean it's better than us having to do it in user space, but it's still not like good for us. Like because the use case in asynchronous JavaScript is different than we do too. In asynchronous JavaScript, I don't think you would typically have like that granular set of like suspension points,
right?
Where we might end up like totally generating tons of continuations in that case. So it might work out a lot worse for us than with usual JavaScript code. I don't know.
Yeah, that was kind of one of the things I was getting at, is that at least the way that preemption works in Erlang, we have to place yield points quite frequently, basically after every function call in function preludes, and I guess also anytime that a GC is required, but that is optional, like that's conditional anyways. But regardless, that ends up slicing up your functions quite a bit, depending on how much of that kind of work they do.
Related to that did remind me. So, mind you, it's two different parts of Google, and of course, parts of Google do not agree with each other, and that doesn't necessarily mean this will help with forcing it. But I did recall that Go also is like fuck asyncify, because it turns out that the way Go routines work is it's not just Go routine functions that do this, but the way that Go is written is that at every function call, so kind of the same way Erlang does it, is it potentially can preempt that function to go service a Go routine running in the background. So they also have yield points at every function call, the kind of the same way we're doing it. And so potentially, Google JS, don't fuck up JS Google, and Go Google will have to agree with each other, and maybe it'll help us.
Yeah, I mean, I think that the more we can kind of lean on that not being adequate for the kinds of use case that we're trying to solve, the more we can maybe get conversation to shift back a little bit to try and address our concerns more directly. I mean, I'm fine with them chasing down how this stuff integrates with async, because I do think that's valuable. But it also kind of ignores what stack switching is about. Like, this is the stack subgroup, not the async subgroup. And there is some overlap perhaps, in the sense that when you suspend execution, there might be some question of, being able to make that a first class object and switch between them. But so far it's been much more kind of focus on the async side of the equation than actually having multiple threads of execution. But I don't know, maybe that's also just my, kind of impression and not so much the reality. I've missed like 2 of the stack subgroup calls in the last like 6 months. So there might have been some conversations I missed out on.
I just realized, Brent, I misspoke. The stack subgroup is every 2 weeks, so it's not a monthly meeting. So it's a little bit faster than that, but
yeah.
So it looks like on the 22nd, it's a implementing algebraic effect handlers in C talk. So we're back to effect handlers at least. We're not on the JavaScript async integration anymore, so that's good.
I just want to be aware of the time. It's 11 a.m. and we haven't gotten to Hans's update yet. If
Hans, you want to go?
I don't have all that much as an update, so
okay.
You keep going.
Yeah, and my only update was presenting how we used JavaScript promises in the Rust implementation, and I emphasized very clearly that this isn't how the compiler works. And I emphasized the fact that like us having to queue the frames meant that was because we don't have yield support. So I'm like, this isn't a good way. I'm just saying promises do work, because someone was like, oh, promises wouldn't work for that because reasons. And I'm like, they do work. It's just not great.
Yeah, I mean, we were able to make it work for our case, I guess, but it's, definitely not as clean as it could be, I suppose. But yeah, if we could directly integrate with like first-class async primitives, then we could absolutely take advantage of those with the compiler, within a single thread of execution. That way we'd play nicely with browser function calls, regardless of whether they're async or not.
This all comes down to that we really, really don't want to do we want to do as little as possible on like the WASM heap of like our stacks or like tracking stuff there. We want to use the host stack for as much as possible, and that's not something async really helps us with at all. It's basically the same as not having anything in that sense.
Yeah, exactly. I don't know. There's definitely, progress happening. It's just very slow. So I figured that, we've reached a point where we probably need to try and at least get something going that can bridge the gap until that stuff develops further. So, that was a major motivation behind reworking some of the code gen layers there so that we can actually do that. And at the same time, it lets me also, represent our, async control abstractions in a way that's platform agnostic. So that's, part of what I've done there is made sure that at least at the high level, when we're lowering into MLIR, we have one way of representing a program that has all the control, switching visible there. And then when we actually lower that to a platform specific version or dialect of that, that's where we make choices about what that control abstraction represents. So for most of the native targets, essentially most of the control pieces disappear and it's just the suspend points. And then on WASM, it will be essentially all of the stackless coroutine stuff. But yeah, we'll see how it plays out. I am expecting that it'll probably be 2 or 3 weeks based on the amount of work I can do each week before I'll have that fully fleshed out. But after that, it should be pretty quick for us to actually be able to compile something for WebAssembly. So that's the hope.
Yeah, I would definitely say it wasn't wrong to try to get on the WASM community, because like without us pushing for it, there wouldn't be this actual use case of like, we actually need this, Erlang actually needs this. There'd just be Google with their async and like Go. maybe. So it was good that we joined and we're pushing for it. It's just we should have realized the committees are slow.
Yeah, I mean, I think we knew that, but I think we, anticipated that there would be, it'd be easier to move forward on something. And instead, what we're finding is that there's considerably more pushback for various reasons that we couldn't have anticipated, like the way that this integrates with JavaScript and stuff like that.
How open or willing are the committee members to hearing our needs? Because my experience with committees is that sometimes they're more just there to satisfy kind of optics in the community more than actually being to serve the need of actually coming up with a like ideas. Like in this case, we see a lot with web spec groups is that what ends up being the case is the vendors kind of decide what's going to end up happening.
I mean, that's always the reality. They dictate the final direction.
That's technically true because like the community group is just advisory. Like the working group makes the decision. It's just the working group has never disagreed with the community group yet.
Okay.
And I would say that WASM is acknowledged as outgrowing just the browser. And so like if there's like we need this for other reasons, it is like they're willing to listen to it. So like all the SIMD stuff and machine learning and like all the proposals now acknowledge, that it's being used for secure enclave computing and other thing, and it's very acknowledged. I would say at least for the stuff immediately, like since the stack group has existed, like I've talked about and Paul's talked about it enough that like Erlang gets mentioned as like the exemplar language that needs to be targeted. So I think we're doing great that way. It's just that they're very cautious because they don't want to get this wrong.
Well, yeah, no, I totally appreciate that part of it. And that's where kind of the dichotomy exists, right? So you have the kind of business needs of getting something out there sooner rather than later, and regardless whether or not it's good enough, pushing forward. And then you have more of the, I'll call them artistical needs of getting something that is nearly perfect. And that's where I've seen kind of this process come to a head, where because WASM is not just like WASM's not working in a bubble, right? Like it's actually a technology that's competing for mindshare against other offerings, say like native type offerings on the mobile platforms or native ways to build out native binaries for server platforms. And the longer it takes to get done, the less kind of impact it's going to make in that space. And this is where like Ember, not to go back to Ember too much, but this is where Ember really failed in that it went down this like route of trying to create consensus amongst all the members in the community for feature development, and it significantly slowed down feature deliveries to the point where the competition just like cruised on past them. And I mean, we saw that with the original W3C, right? Like the only time W3C actually got their shit together and acted is when Firefox and Chrome said, screw you, we're going to start, building things out faster than you're telling us what the specification is. And now they essentially have been overridden by the Watt WG. So I understand the frustration of the working groups, and I wonder if it is going to significantly impact this project's ability to win mindshare back when we are able to release in a manner that is recommended for production builds.
I mean, the answer really is going to boil down to how things look with, you know, the Asyncify approach. If it works pretty well and, you know, it doesn't have any real nasty pathological performance cases, then shit, maybe it's good enough. If we find though that it works in basic cases, but is too slow for, you know, more complex types of problems, then we would be effectively blocked on getting a proper solution to this stuff. And
Right.
that would definitely put a, you know, halt on our ability to keep pushing forward on the WebAssembly side. You know, that doesn't mean that it stops other aspects of the project from continuing to develop, but you know, since WebAssembly was kind of the primary driving force, you know, it would really, really be unfortunate if we have to wait indefinitely for progress in these working groups.
Yeah, I mean, I think part of what I was getting at is, at what point is it more beneficial to the success of the Lumen project to implement workarounds that, while not performant and while not going to align with what the spec will eventually be, gets us out the door, starts generating interest in the project, and as these specifications start to land, backporting that support into future versions.
Yeah, I mean, as this stuff starts to develop, we can obviously take advantage of it. You know, this is, again, just kind of like a bridge to get us to that distant future where those things are fully fleshed out.
Okay. All right, let's, we're 11:12. I have to jump into another call.
Same.
All right. Thank you, everybody.
Talk to you later.
Bye.
Bye.